Welcome to CodehubIndia. Today it is the physics lecture class, and you guys will understand, learn very important chapter that is pertaining to the temperatures, expansion, ideal gas law, etc. We are expecting you should go thoroughly throughout the course, and we are assured that you certainly grab the thing properly. So everywhere in the world there is a existence of temperature, and that is the means of to measure the heat. Everything of the made of atom, the idea was only fully accepted through the 100 years ago, because Einstein analyzed Brownian motion, that everything inside the molecules are moving in a random motion. There is a collision. Due to collision between the molecules and element of the molecules is generated, and they pattern in a zigzag and random manner, which were estimated in 1827, and later it is found is jiggling with dead stone found. Later on, size of the matter, that means the atom and the mass of the atom, have been first compared with the hydrogen, which is the most basic and elementary element of unity, and it were concluded that the hydrogen atom is about 10 to the power minus 10 across the other a few times by bigger, and Avogadro number were defined that in 1 gram of mole which contain the atom, the number of atom or molecule, that is 6.02 into 10 to the power 23, that you have to keep your mind, which is called as a Avogadro number. One molecule in Avogadro number, the net volume of that is maybe in gaseous state, then it will be 22.4 liter volume at normal temperature and pressure. So always you have to keep in your mind the Avogadro number, and on basis of Avogadro number, the volume of that is 22.4 liter at NTP. Similarly, the atomic mass unit is 1.66 into 10 to the power minus 27 kg. The mass of the molecule is atomic mass unit equal to mass of the Avogadro atom in gram. 1 gram hydrogen oxide is 18 gram. We know H is 2 and O is 16. So 16 plus 2 equal to 18 gram. This is just a reminder, we should more familiar with the chemistry. Now the Mr. Clicker came and put a question that what is the probability you breeded one just now in your most recent bet? The probability may be 1 in 10,000, probability may be 1 in 1,000, probability may be 1 in 100, or probability may be any like whatever you think. So measuring a temperature is a simple analogy. We can tell by touch something hot and cold. We can feel a temperature, but from where it will start, that is our assumption. So in the first year's attempt measured temperature was by Galileo in 1597. A glass bulb was long thin neck, filled with the immersed liquid. As the temperature varies, the gas in the bulb changes volume and sucking up the liquid or pushing it down. Due to increase in temperature, changing in temperature, the volume of the gas inside that changing. As you change of that, the liquid is pushing, giving the up or down motion. From there, the Galileo thermometer, no good for the company. Galileo developed a thermometer. And for the day-to-day use, the Galileo thermometer was not found in order. The reason is that the fluid would evaporate. What fluid are considered in the Galileo thermometer, that is evaporating temperature in normal working of the environment. It is limited for reading. The range of the temperature reading is limited since it is a gas expansion. That instrument called the barometer also. Now the thermometer have arrived. After barometer, thermometer have arrived. The thermometer are in two types, centigrade and the Fahrenheit. The thermometer are used for the expansion of liquid as a measure of the temperature. The temperature were calibrated on the basis of ratio of the expansion of the liquid and temperature were measured. That you know, the boiling temperature of the water, it is 100 degrees centigrade, and freezing at a point of a water is 0 degrees centigrade. Similarly, the boiling point of water in Fahrenheit scale, it is 212 degrees centigrade, and the freezing point of water in Fahrenheit scale, it is 30 degrees centigrade. And they have calibrated the thermometer, which is charged with the gas, liquid, expansion liquid, and due to that expansion, the scale we have calibrated. So we have to know that how to convert between them, how to exchange the data between them up to a scale of this Celsius, that is centigrade, and the Fahrenheit, that is written as F. When two metal differing expansion rate, if two metal, one is copper and another is aluminium, are joined together, and after heating on it, it's make a robust thermometer, because one metal may be a less coefficient expansion and another metal may be a more coefficient expansion, then another metal expand more, but the other metal is expand less. and this make a deformation in the welded strip of the bimetallic, and that deformation can be calibrated to make a good thermometer. That was also experimented, but now it is not in use other than some advanced engineering. General purpose thermometer is the mercury thermometer that we are using. The mercury thermometer, the mercury have a lot of properties, is very linear for our uses of our regular basis in the different field, that environmental temperatures and biomedical health, biomedical everywhere. The question is that what is zeroth law of thermodynamics? If two things at a different temperature are in the thermal contact, so the heat can flow and no heat is being supplied from or being drained to environment, they will reach the same temperature. Zeroth law is saying if two different temperature, two things at different temperature in the thermal contact, heat will flow, and if we consider there is no transfer heat to the surrounding, suppose this is a plate, this is another plate, and your surrounding is what? Around your air. It is insulated from air. The surrounding is not affecting on the heat of the things. Then, under that condition, both will reach a same temperature after a certain time. That we know very well. We are putting the boiling milk, put the ice there. It will ultimately equilibrium and ice will melt it. The temperature will be equilibrium in a constant temperature. It will come because it is homogeneous mixture. The milk is homogeneous mixture, and that is called the thermal equilibrium. The zeroth law states that if A is a thermal equilibrium with B and B is a thermal equilibrium with C, then A will also be thermal equilibrium with B. It's simply accessible. If A equal to B, B equal to C, then A equal to C. It is the, if it is not going, the thermal should meaningless, and thermodynamics guy like to. Anyway, then what is thermal expansion? If it is a linear rod and it is heated, the rod will increase. This is the basic of expansion. And the order of the total expansion, it is a multiplier of 10 to the power minus 5 of the original. So it will expand at the order of 10 to the power minus 5 of each Celsius centigrade in same proportion direction too. This means there will be only change of one part in 1000 over 10 before over a 100 degree temperature range, so that the change are not visible to the naked eye, open eye. What are the changes? Very small changes, 10 to the power minus 5, very small. Some multiplier are there as per the, but they are also very 1 and 2 range figures, depending upon the measurement method. So it is not at all visible and the 100 certificate is a part of 1000, fraction of 1000 value. Sorry. In open eye we cannot see. So we need to detect how to detect the expansion, length of expansion. So coefficient of expansion, if we consider the linear expansion, if the rod of the negligible dia, very small dia as compared to the length, big rod length, it is small dia. So we consider the linear. If dia is more, then we will consider the volumetric also, on y-axis also, and x-axis is a linear shape. Rod is kept across this x-axis. That linear expansion is defined as alpha. You see the coefficient, the cofactor of the indices of 10 to the power minus 5 is around less than 2, it is 1.2, above 2, 1. That is why it is told that for the iron it is 0.9 for glass, and iron it is 1.2. So what is this? That coefficient of linear expansion is what? That is called alpha. Change in length divided by original length into coefficient of linear expansion and change in per unit temperature. So if I put the alpha equal to change in length ratio divided by per unit temperature. Per unit temperature, of which there is a change as compared to actual length, and is defined as alpha. Similarly, if you consider the volumetric, entire volume, if the dia of that elongated rod is not so small as compared to length, so we should consider volumetric, and that is defined as beta. So there was a del L, a small change in length, there is a del V, a small change in volume, original volume, divided by beta into del T. If del T considered the 1 degree centigrade, a 1 unit of the temperature, then beta equal to rate of change of volume, okay, with respect to original volume per unit temperature. Simply try to understand, if I know the value per unit rate of change of volume with respect to original volume, rate of change of length with respect to original length per unit temperature changes is called the linear coefficient expansion, and rate of change of volume with respect to original volume per unit change of temperature is called volume expansion. Clear? So we know there is a, if it is cylindrical, rod is cylindrical, so we can calculate the volume of rod since we know the height of the rod and radius of the rod, the width, radius, circular section of the cylinder. So there is a relation between the length and the volume. Accordingly, we can make a relation between the alpha and beta, linear coefficient expansion and the volumetric coefficient expansion. So it is not at all a problem, it is explained here. That imagine a cube of the solid, here it is considered not cylindrical rod, it is considered a cube, because it is considered a cube to explain in very comfortable mathematical calculation, a cube unit length of the all sides to help you give the calculation. So volume is L3. Okay. With unit increase of temperature, that is del T, unit increase of temperature, the length of the site goes to what? Original length, that is L, plus what is value of that alpha into del T into L. Then L have taken common there. Original length, that was the original length before increasing the temperature of 1 unit. And due to change in temperature, increasing of temperature of del T of 1 unit, the change in length is alpha into L. So after taking the common of the L, it will come to L within the bracket 1 plus alpha del T bracket close. Any problem? No problem? Thank you. So what is the volumetric changes? The volume of that cube is L to the power 3. Then it is on linear consideration. If alpha value, the volumetric is whole to the power 3. So now del T is a very small number, and power of del T is negligible, because if I having a number is 0.1, that is 1 by 10. If I square it, then it will become 1 by 100, more small. So a small number less than 1, on the squaring it becomes more small, and that number we can very comfortably neglect it. That is too small that we can neglect it to make the mathematics very easy. So here we are breaking that L to the power 3 of the whole cube. That is a simple formula, you know. A plus B whole cube is equal to A2 plus B equal to A square B plus 2 to 3A square B plus B square. That is kept here. And what are the del T square and del T cube have been eliminated, neglected? So ultimately what they are getting? That L2 1 plus 3 alpha del T is also tiny, and for the solid it is almost equal to 10 to the power minus 5. Must have multiplied of 1 and 2, because you know in the previous that the difference of the iron and the glass is around 1.2 to 0.9. What is the fraction of that? That is 1 and 2, that is 0.3 difference. So almost 10 to the power minus alpha. And beta is what? It is 3 times of the, because the volume goes to 3 into this beta, then beta is almost 3 times. Any problem? So you got the alpha beta relation, that beta equal to 3 alpha. On approximation, putting out the decimal figure. But when you go to instrumentation engineering, in engineering application for sophisticated biomedical engineering, we have to consider the fractional error factor also. Anyway, the question is coming that if you have a square brush plate with a hole in it at the middle of it, and if you put it to reach a high uniform temperature, then immediately measure the hole very accurately, what will you find? The hole is bigger than that was before heating. Hole is smaller than, or hole is same size. Very conceptual. So try to understand. With a plate, there is a hole at the center, and it is dropped on the heating high temperature. what will happen? Whether the hole becomes smaller or bigger or same size. Why? It is span. They span this side also. Understood? Next, it is what the coefficient of linear expansion of aluminum is 2.5 into 10 minus 5, and aluminum plate of this and this size is heated up to 20 centigrade. By how much does its area increase? It is the what? It is the 2 into 3 centimeter. Then 2 will increase how much? 2 is increase how much? That with that 2 plus 2.5 into 10 to the power minus 5 into 10. You will get the value. And 3 into next is 3 into 3 plus 3 into, sorry, the coefficient is 2.5 into 1 minus 5 into temperature. Change in temperature, change in centigrade, that is increase in temperature, then we will get the increased length also, and increased length of total length of bit, you got it, and multiply it, we will get the area, how much area increase. The original area is how much? It is 6 centimeter square, and after heating it becomes something more. That area multiplied after minus the 6, you will get the increase. And give the reply. Any problem? Now next question. Similar question you are having now. That here is a given the point of density. What is density? Mass per unit volume. So here is the requirement of the volumetric expansion. I think, let me hear it. The coefficient of linear expansion aluminum is a solid aluminum sphere is heated up to 1 degree centigrade. What is the fractional change in density? Before heating, say the radius of that sphere is what? Then before heating it is what? Pi. Pi r is the volume of the sphere. And after heating, you know the alpha is 3. Then beta is how much? 3 times of the alpha. So we can calculate the resultant volume equal to volume plus beta into volume into change in temperature is 1. So no problem. The original volume is pi. Then new volume we have received that from the calculation. New volume, then the new volume minus original volume equal to change in volume. You can calculate. So volume expansion coefficient of a liquid, if I consider liquid, so far we are concerning now we have arrived at liquid, because you see the thermometer is used for mercury, which has the low coefficient, expansion coefficient as a liquid. That expansion of coefficient, if you consider the increase in temperature and if it's a low coefficient expansion, that means that it can measure the small changes in temperature. And whatever the coefficient expansion of the glass of the thermometer, that is too high and that effect is continually 20 times. If you consider the intermolecular space of a gas is more, which occupies the more volume, and it goes to always takes place in the upper places. Unlike the liquid, expand cooling from the 4 centimeters for freezing. Sorry. So, if we consider the water, the volumetric changes 10 to the power minus 3 from 10 to the 0.15. That is have been calculated. Then question is there, in a mercury glass thermometer decided to upgrade his product to Pyrex glass, which hold up the better of a high heat because it has a lower compression expense. He makes the new thermometer identical to that old in all diameter. To check the product, he put the new one and an old one together in water and heat the water supply. What does he see? Mercury is new one rise faster and mercury is old one rise faster. They both rise at the same rate. Here, selection of the glass depending upon your application. Application means what is the range of temperature it is required to measure. If you are going to measure the human body is 90 to 167, 90 or 30. So the coefficient of glass is not making any sense. If you consider that they have a high temperature, at that place the glass will get down. We got a good glass so that it can withstand. So Manufacturer Mercury glass thermometer decided to upgrade this product by Pyrex glass, which is hold up better to high heat. Because it has a lower coefficient. It makes the new thermometer identical to that of old thermometer of all dimensions same. Check his product together in water, heat the water slowly. What does it see? Both thermometer insert into water and heat it. Then which will push up more? Pyrex thermometer or old ordinary thermometer? Will rise faster. New one rise faster. Old one rise faster. You try to think the V plus V into beta into temperature. And the multiplier of the new glass is less as compared to old glass. So glass will expand less, but the mercury will expand equal in both, and both thermometer diameter is same. The will rise faster. Old. It's clear. The Boyle's law will teach you tomorrow. temperature chapter have been finished, and do exercise from your book. Okay, we will give you the video in due course after 2 and 3 hours. Okay, thank you very much.